All right, in this video, we're going to be talking about how to integrate vectored value functions. So remember, a vector value function is just a function where the x component is given to you by a function and the y component is given to you by a function. So taking the integral of that vector value function just means take the derivative of the x component with respect to t and take the derivative of the y component with respect to t. Another way to extend this, actually both smaller, would be capital F of t plus c1, so that constant of integration, and then capital G capital G of t plus c2. So those constants of integrations are going to be different. So this is the same thing. F of t plus c1, G of t plus c2. Yes, I should have just waited and wrote it there. All right, if I'm doing a definite integral, it's going to be very similar. It would be f of t evaluated from a to b, and then the antiderivative of g integrated from a to b. So basically just doing double all the stuff that you already know how to do. So let's do a couple problems, make sure we realize that this isn't too bad. All right, first example, find the antiderivative of the vector value function given to you by t squared and the natural log of t. So this is going to be equal to the antiderivative of t squared, which is 1/3 t to the third power plus c. I'll call it c1. Then the other one, the antiderivative of natural log of t. So when I'm doing differential equations, a lot of times we get to something like this. And when we anti-differentiate, I would get the natural log of x. But to find the antiderivative of natural log, some of y'all might have it memorized, but we're going to do this using integration by parts. So if I want to integrate the natural log of t with respect to t, I'm going to say u is equal to the natural log of t, and dv is equal to dt. So du, the derivative of that was 1/t dt. The antiderivative of dt would just be t. So this would equal u times v. So u times v minus the antiderivative of v du. Du is 1/t dt. So carrying this down, this would be, I'm going to write this as t, natural log of t, just put that in front. The antiderivative of 1 with respect to t is just t. So the antiderivative there would be t, natural log of t, minus t plus c2. And that would be the antiderivative. All right, so for part B, it says find r, and r is the antiderivative of r prime. So this is just saying integrate this vector value function, basically. So I'm going to say r of t is equal to, what is the antiderivative of secant squared t? That's tangent t plus c1. The derivative of tangent is secant squared, so the antiderivative of secant squared is tangent. And then the antiderivative of 1/1 plus t squared is tangent inverse of t plus c2. So just find the antiderivative of each piece, and the constants of integration will be different for each one of them. So we call one c1, the other one c2. All right, let's keep going. So this time it's a definite integral. So we find the antiderivative and we plug in the limits of integration. So antiderivative of e to the negative t, which would be e to the negative t times the chain I guess I would do u substitution here basically. U is equal to negative t, du is equal to negative 1 dt, and there's where your negative 1 comes from. And we'll evaluate that from 0 to 1. The antiderivative of 1 over t plus 3, just talked about that a second ago, be the natural log of t plus 3, evaluated from 0 to 1. So now we plug in our limits of integration, negative 1 e to the negative 1 minus negative 1 e to the 0. And then if I do it over here, the natural log of 4 minus the natural log of 3. Cleaning this up, what would that be? Negative 1 over e plus 1. And then this I could rewrite as 1 as natural log of 4/3. All right, next one. All right, so same thing. And the antiderivative of t cubed, so t fourth times 1/4, evaluate from negative 1 to 1. Add 1 to 1/5, get 6/5. Multiply by the reciprocal, 5/6. Evaluate from negative 1 to 1. Okay, that'd be 1/4 times 1, which is 1/4, minus whatever you want to put 1/4, and then over here 5/6 minus whatever I get when I plug in 5/6 there. So what, 5? Just a second. So if I plug in negative 1, it'd be 5/6 times negative 1 to the 6/5. So this one over here is 0. Okay, the 5th root of negative 1 to the 6th power. Okay, so that's just 5/6, so it's just 0, 0. All right, let's keep going. Okay, vector value functions and initial value problems. Okay, so find R. If R of 0 is 1/2 1. Find R of this. If R of, okay, so this is just, it gives us an initial condition. It's going to help us to actually find the C number. All right, so R of t is equal to, okay, find the antiderivative, integrate each part. So what, u is equal to 2t, du is equal to 2 dt. So this would be sine of u times 1/2. So the antiderivative of that would be negative 1/2 cosine of 2t plus c1. Find the antiderivative of this. There's tangent inverse of t plus c2. So if I just said find r, just integrate both sides or each part. But this time it gives you initial condition. It says if t is 0, then the x component is 1/2. So that means if I plug in 0 for t, I should get 1/2. So that gives us an initial condition to find C1. So what? Cosine of 0 is 1, so it's negative 1/2, plus C1 is equal to 1/2. Add 1/2 to both sides. C1 is 1, so R of t is equal to negative 1/2 cosine of 2t plus 1. Okay, so do the same thing over here. It says tangent inverse of 0 plus C2 is equal to 1. So if I plug in 0, I should get 1 for the y component. Tangent inverse of 0 is 0. So C2 is 1. This is tangent inverse of t plus 1. All right, there we go. We just did what it asked us to do. All right. Letter B. same type of problem. So this might be a good place to pause the video, give it a shot, and then unpause it and see if we got the same thing. All right, so find R if the derivative is that, but the initial condition, if I plug in 0, I should get 2, 0. So find R, which is the antiderivative of R prime. So basically, find the antiderivative, integrate. So the antiderivative of that, okay, so u is equal to 2t, du is equal to 2 dt. So this would be integral 4 e to the u du, but in the du, there's an extra 2, so multiply by a half. That would be 2. So this would be 2e to the 2t plus c1. Antiderivative is just e to the u, so e to the 2t, and then 2. Okay, antiderivative of 2e to the t is just 2e to the t plus c2. Okay, plug in your initial conditions to find that constant of integration. So for this one, it says if I plug in 2, I should get 2. So this would be 2e to the 4th plus c1 is equal to 2. Oh no, if I plug in 0, whoops. If I plug in 0, I get 2. So this is 2 plus c1 is equal to 2, so c1 is equal to 0. If I plug in 0 to the y component, 2e to the 0 plus c2 is equal to 0. So this is saying c2 is equal to negative 2. So final answer, 2e to the 2t plus 0, which don't even write that, and then 2e to the t plus or minus 2. All right, I'm gonna pause this video, take a little break, and then make the other video the other questions have the other video. So thanks for watching. Hopefully it helped. Bye.